Thank you for hanging in there. This has been, I'm sure, a lot of information to absorb at one time, so I'm so happy that everybody's still here. Just a little bit about myself. See if we can get this going. Oh, there we go. Just so you know who I am, my background, I was a systems engineer for most of my career working for big companies. I worked for Citigroup working on their mortgage portfolio in a high-performance computing. And then before I started this company, I was working for a cloud provider doing cloud research and development. And during that time, got really excited about containerized technology, about schedulers and things like that. So in 2014, I founded a company in St. Louis around those technologies. Today we have 10 employees, plus we're getting about 3 or 4 interns this summer, and we have a lot of really great customers. So just about me, I'm a systems engineer who started a company around a lot of this stuff. So we're going to talk about building a modern infrastructure stack, and kind of, I want to, thinking about what I heard about a lot today, because I too was very overwhelmed by everything. And kind of what I want to talk about is the coming infrastructure crisis. So you've been exposed to probably dozens of buzzwords. I got this from, I just downloaded this today, and this is kind of like an overview from December of a lot of the players in the microservices. And each one of these is probably a VC-funded company, and every single one of these is invested in with the investors thinking they're going to make 10 to 20 times their initial investment. So a lot of these products and things that you've been hearing about today are, they're coming from companies that need to make their money back, and it's really complex, and I think you're hearing that. And then when I was looking at this, actually, I was looking at some of the things, I'm like, that doesn't make any sense. So this is what I thought about, right? This came from Boundary.com, where like somebody was just putting up logos there. And the funniest thing about this is that Boundary.com got bought out by BMC, so I was trying to cite this image, and I couldn't because it was another promising infrastructure startup that disappeared. So kind of what I want to say, and you're probably feeling it too, it's like, it's incredible the amount of new tools that are coming out. And how are we going to deal with it? Because it's probably beyond anyone to actually manage this. But before we do that, what I'd like to do is really talk about who we're doing this for. So we want to first talk about our customers, the people who are developing and using our systems. And I think when we think about the people who use our tools first, then we walk back from that and design software for them. When I go talk to a lot of customers, we go in there, there's usually several groups of people that have differing demands. The first one is there'll be someone from the developers group, there's a lot of folks from the analytics group, and then there's usually somebody from IT there, right? So when we go into an engagement to talk to somebody for a larger company, they usually have these kind of folks there. And when you talk to them, they have different stories. The developers, the number one thing that you talk to, they want continuous delivery. They don't want to have to go through ops to deploy things. They're moving to microservices. And something that's very important too is they're really moving towards API-centric, right? Where everything talks to everything else via API. And this is to enable things like mobile development. And they're using tools like, using tools like Groovy. They have still some legacy Java. There'll be Node.js. Now, when you talk to the analytics folks, this is a whole different group, right? It's a different part of the company. They report to different management. And traditionally, these folks were using tools like SAS and Oracle, right? And now they're moving into big data. And when you hear what they're talking about, right now, it was big data. Kind of streaming is the hot thing right now, especially with tools like Kafka and Cassandra and real-time data. They're moving from really starting to get into things like predictive analytics, machine learning. There's a lot of open source libraries there. And of course, events, like getting back to Kafka. Now, you'll notice is that big data people and container people are like completely different worlds from each other. The tools they use are different, the languages. And then finally, this is always good for a lot of tension when you go talk to big companies, is the IT folks. Usually they're spending almost all their time doing maintenance of existing infrastructure, and they're being pretty much screamed at by the other two groups. How are we going to move to continuous delivery? How are we going to move to the cloud? How are we going to get this Hadoop infrastructure, right? So I've actually been in meetings where people start shouting at each other, especially between the IT folks, because they feel pressure and they really don't have the training or personnel. They have the ability to do it, but they're kind of trapped. So that's what we talk about. When we talk about these platforms like Kubernetes and Mesos and Docker, what we're really talking about is like, how does this actually affect organizations? Like, what are they going to use it for? So let's talk about the problem. Infrastructure is getting way too complex. We have an explosion. I kind of show you that thing, but just just to get an idea of this, these are just kind of tools that have popped up in just the last couple of years. And what we're seeing is, you know, especially on the code side, there's new languages like Go is really taking off on the infrastructure side. I was saying kind of the decline of Hadoop. Spark has really taken over for a lot of analytics programming jobs. And we're seeing basically a new JavaScript framework pretty much every week at this point or sooner. On the data side, what we're seeing is really specialized databases. Like in the old days, you just have a single SQL database. And now what you're finding is you have a database for events, you have a database for documents, you know, you might have a database that's like a Ring database like Cassandra. And then finally, runtime. A lot of things we're talking about today, you had, I think, 5 different vendors talk about. You had Nomad, you had Kubernetes, you had Docker Swarm, you had Mesos, and you had Cloud Foundry. Right? So you have 5 different platforms, and you know, so we're seeing an explosion of different tools. And of course, you say, hey, we'll just go to Amazon or something like that. It'll make it easy. But anyone who has ever used Amazon knows it's incredibly intimidating, right? This is what Amazon, and if you look at like what the traditional IT thing is, it's that EC2 up there, right? It's deploying instances, right? So Amazon is like, the first time people go to Amazon, it's like, oh my God, there's so much to do. And you can click around and get things done, but making that repeatable is not a good way of doing it. So basically, the cloud is complex. You have to learn how to do the cloud, and there's a bunch of tools. There's an explosion of tools, especially in the era of GitHub, where every company now is developing out in the open. So pretty much every week there's new things coming out. IT can't keep up. We look at IT today, and it's kind of like this, right? You know, it's like, and a lot of folks have talked about this today. You have to open up a ticket with somebody, and it takes forever. But all the talks today, too, have been like very aspirational, right? Like, we want to get to this. You know, how do we do it? Like, we want to be like Google, we want to be like Netflix, we want to be like all those companies that talk at velocity that basically are just, you know, pushing a button and things are going. So that's the problem, right? Like, to get to that level of that high automation, it takes an enormous engineering effort. Like, you talk to these companies like Google or Netflix, they have multiple SREs working to automate their infrastructure. It's incredibly expensive. And for companies who usually have just a handful of people to do this, it's way beyond their abilities. So the question that we have with this Mantle project, it's like, what if we made it easy for normal people to spin up world-class infrastructure in just a few minutes, as opposed to what we usually see for IT projects dealing with containers is like 1 to 2 years, right? So that's kind of the goal of our project. And that's the project is Mantle. So that's what we're going to be talking about after this introduction, and it's at mantle.io. It's Apache open source. It's sponsored by Cisco. And really, the goal of this is to make it easy to run containers and data workloads. So just a couple things before we get into the architecture of it, because I'm going to spend the rest of the talk being a technical talk about how we do it. Our first goal is we wanted something that deployed in minutes. Right now, it takes about 20 minutes to deploy on most clouds. We want to cut that down. When we talk about supporting diverse workloads and tools, what we mean there is we expect a lot of these open source tools to have a limited lifespan. Like, there might be one that lasts for decades, but most of them are going to have a popularity curve of like 3 to 10 years. When you look at like a lot of example projects in open source, a lot of them don't have HA, they don't have security, they're not integrated with logging or anything, right? And that's really the problem. When you download an open source project, most of the time it doesn't have that, and then the vendors want you to pay a lot extra. And then finally, we really are passionate about making something open source. So this is what a Mantle cluster looks like when you deploy this to any cloud. And this is a pattern that you'll see almost any of the platforms you roll out there, whether it's Mesos or Kubernetes or anything else. You'll have an odd number of control nodes. And this is a pattern you use if you're using any kind of consensus system like Zookeeper or etcd or Consul. You always want to have an odd number, so if you lose a node, you still have a majority election. So we have a set of nodes that are called control nodes. Then we have worker nodes that could run different types of workloads on them. So we have examples here of Kubernetes and Mesos. So the way we run these schedulers on Mantle is that we actually separate them. Like, we don't run the Mesos Kubernetes scheduler. We actually have a Kubernetes deployment and a Mesos deployment that kind of work side by side on different nodes. And then finally, we're using a tool called Traffic, which is a dynamic load balancer that kind of on the fly will direct traffic into the cluster, right? And one thing you're going to see here is that we have a lot of flexibility to pick the tools that we like the best and integrate them. So we find, and that's really important for us. Like, we don't want to have a strategy tax that we pick something and then just because it has to work with all our other tools, and so we can lock people in. And Casey talked about this, and we're going to talk about, for the rest of this talk, kind of the layers of the stack. So when you talk about, hey, I want to run Docker, it's very exciting, it's easy to get up, but then when you actually start talking about what it takes to run Docker containers in production, and Casey alluded to a lot of this, you find out that you need to run your infrastructure like Google. So this is when I was talking about the crisis in IT, this is what we're talking about. You know, you want to move to microservices, continuous delivery, or roll out Kafka, but then you realize we have VM-based IT, and to get to like a really strong container-based infrastructure is an enormous engineering effort. So we're just going to walk through these, and I'm going to talk about the open source tools that we picked, why we like them. So even if you don't use Mantle, there's a lot of these tools that you could use to build your infrastructure out. So the first one is cloud provisioning. We base all our stuff on Terraform. So Mantle pretty much looks the same everywhere you run. And it's bare metal. Terraform is a tool developed by HashiCorp, and Seth was here yesterday. And what Terraform does is it basically abstracts out the APIs of each of the cloud providers, and it's got a really cool feature where it represents everything as a directed graph. That means if you make changes, only the things that change get applied on the next run. It has really simpler syntax than things like CloudFormation or Azure templates. And the way we do Terraform is very modular, so you could do things like attach volumes to nodes and have separate LVs, and we set up networks and security groups and everything, right? So the first hurdle you do when you're going to the cloud is how do you actually set things up? We usually provision to most cloud providers just the infrastructure from like networking all the way down to VMs in about 2 minutes. So Terraform is great, and these are all the clouds we support right now. We just got Triton support last week. I'm actually working on Azure support right now, so we'll be able to deploy almost anywhere. And if you've never seen Terraform before, this is kind of what it looks like. So if you've seen CloudFormation, it's very confusing. This is hard to read. This is how you would set up a VPC in Amazon. So if you've ever done it manually, you know it's a huge pain. Up there, you see the first thing we do is we set up a resource called AWS VPC. See if that works. And you see this here? There's variables, right? So what we could do is we could feed into Terraform different network values. So basically, we have the same modules in Terraform, and we pass in variables. So what we could do is have matching Mantle clusters in like US West and US East, and we change one variable, and they're exact clones of each other in terms of everything from like IPs and everything. Well, maybe not floating IPs, but static IPs, networks, and everything else. So the cool thing here is we also tag it automatically and we pass in all these variables, and then the next thing is we're going to create a subnet, right? And we just take the ID of the VPC we just recreated, this here, it gets an ID out, and then we set it, then we set the subnet, and then we do things like availability zones. So in Mantle, we could do cool stuff like when we deploy servers, if we give it 3 availability zones, it'll stripe the servers across daisies. And this is something you could do in Terraform pretty easily, but we have it. And then, of course, if you've ever done a VPC, you got to set up a gateway and a route table and all that other stuff that makes you hate your life until you get it all working. But it's all automated, and all you have to do is just basically change some variables like what AZs you want, what region. And this is the same pattern for OpenStack or when Azure comes or Joyent. Now, another cool thing that we do because of Mantle is because we have multiple providers, we actually link up DNS. So in this example, I'm actually linking up Cloudflare with instances that we boot up in any cloud. And what that means is here is we're going to set up a wildcard DNS, right? So that means that anything that goes to like mantle.example.com will go into our cluster. And so that's the example over here, app 1 and app 2. And then the way we set this up in Terraform is we have this module here for Cloudflare, round robin, right? We pass in the edge IP list, and then we have a GOTO domain. So here we're going to do this for GOTO, right? So I set it up, we're going to have an example app. So whenever we build a new edge host, it automatically updates Cloudflare with DNS. So you could set it up every time you build a new Mantle node, it updates either Cloudflare or Route 53 or Google DNS. You just feed in the variables of all your hosts. So suddenly we have something here, how we provision our hosts is going to be tied into actually how we route traffic. Like a lot of the examples you see, people are like going to fixed IP addresses because they don't have that tie between DNS and everything. So that's kind of Terraform. If there's one thing you take out of this, if you're going to do cloud provisioning, I'd really suggest using Terraform over other tools, even the cloud native ones that they provide. I'm going to skip the overlay network part, and I'm going to talk about service discovery. Because this is really a fundamental, it's been talked about here, but it's really a fundamental part of containerized infrastructure, and it's how do applications find each other. What we have in Mantle is we expose service discovery information either via DNS or via an API. And this is what it looks like if you're actually on a cluster. So let's say that you want to find the pricing service. If you do an NS lookup, it'll come back with what nodes that container is running on. And you also have things like you could tag nodes in DNS, and you could also in console, which we're going to talk about, you could actually have different data centers. So if you link up your console clusters, you can actually have lookup services in other data centers. So when you're on a Mantle cluster, basically everything is registered into the service discovery system, so you're not hard coding IPs. So we use Console for this, which is another HashiCorp tool. We think it's really good. We wrote the Mesos to Console bridge. So basically, every time you launch a Mesos task, it registers in Console. We're working with a couple other companies right now to develop, if you know Kubernetes, it uses SkyDNS and etcd for its service discovery engine. Right now, when you deploy Kubernetes on Mantle, we're routing it through DNS mask because we don't have that integration. Console needs a lot of changes internally before it could support the Kubernetes namespacing. If you've ever used Kubernetes, the DNS is like namespace service, cluster local, and Console has a flatter namespace. So that's actually working. So right now it's through DNS mask, but Docker supports Console for service discovery. So our goal is we're going to have a common service discovery. And the other thing too is the things we install on bare metal, like Mesos, that's also registered in Console. So basically every service in the cluster that we put in, we register via DNS. And another thing we get out of Console is Console has this concept of health checks built into it that actually feed into the service discovery system. So everything we put into Mantle, we actually have it Console checking it, within every few seconds. And if there's something down, it'll actually get pulled out of DNS. So this is why we chose Console in the first place, because we want to have pervasive service discovery and health checks in our systems. The huge problem a lot of times is that you deploy one of these systems and then you'll go to your infrastructure team to monitor it, and they'll monitor a few things, but they don't know how to monitor all these things. So our idea was, since Console has service health checks built in, every time we deploy a component in there, it comes with a health check. So the cluster is checking itself all the time. You don't need an external system. And another cool thing is, now we deploy Mantle to a lot of different clusters, and how we unit test it. We built this cool tool called Distributive, which is like server spec, but it's a single go binary, and you give it a JSON. That's it. It's the simplest way to test your infrastructure. And when you give it that, you say, hey, I want the systemd service enabled. This port needs to be open. This file needs to exist. This file needs to have this code, right? So when we deploy a cluster, we actually just put in all the checks with it. And the cool thing is, since Console has health checks built in, the same test that we use for unit testing our clusters runs within Mantle itself all the time, right? So a lot of times you have, how do people actually test their infrastructure? I don't think anybody's really doing this right now, but this is what we do, right? It's kind of, we think it's going to be a very important pattern going forward. We have, infrastructure checking. So we have kind of that combination of monitoring and unit testing in the same go. Like when we deploy a cluster in Travis, we just hit the Console API. We just have to hit one Console API and say, is anything unhealthy in the cluster? And that's the same thing you can do. So that's a pattern that we're talking about, like this pervasive health check and monitoring. Okay. I know I'm going fast, but there's a lot. Secrets. If you heard Adrian's talk before, which was really good about Docker secrets, this is, if you've ever used Docker containers and trying to get secrets into them, it's an enormous problem. There's a lot of hacks going on right now. It's really hard. Like there's things like when people boot a container, they'll pull things from S3, or, in the traditional days, you only had a couple app servers, so you could copy everything manually to the servers. Nowadays, if you have a larger cluster, you don't know which secrets have to go to which nodes, and either you're copying everything. So right now, there's just like not a lot of good solutions for this. And this is pretty much everywhere I'm visiting right now. They don't have anything good. So what we're doing within Mantle, we're using another HashiCorp tool called Vault. Right now, it's part of a tech preview. We're slowly integrating it. We're going to use it for things like PKI and storing secrets in the cluster and doing other things. And bringing up Vault itself was kind of a pain too, so we've automated it. And we also have just developed this, released it as a 1.0. We have a Vault FS. So what you do is when you boot a Docker container, you just mount this is a virtual volume as a Docker. So like, let's say you'll be mounted at /secret, and it'll pull the secrets out of Vault. So when you bring up your Docker container, your developers will just know to look at /secret, and that's where all the credentials and keys will be. So that's kind of how we're going to do it going forward. And I'm very excited about this because I've worked with a lot of customers on getting their Docker infrastructure up, and it's pretty terrible right now, the amounts of security that they have. So I'm very excited about this. So this is, VaultFS just came out of 1.0, so we'd like people to test it, and we think it's going to be a really good solution. And we'll hopefully totally integrate it within Mantle in the next couple months. There's just a lot of security things we have to do beforehand. I took out all the slides explaining what schedulers are. I think you guys have heard enough about them. Right now, we support 2 different schedulers. There's Mesos, and with Mesos, we have integration with Console and Calico, which is an overlay network. We're also looking at Contive, which is Cisco's overlay network product that's going to integrate with ACI, so you can have all kinds of enterprise corporate strategies. We just added Kubernetes 1.2 support, and we'll also have Console integration and Calico. And we just right now have Docker Swarm in development. And right now, when you deploy the cluster, you get both Kubernetes and Mesos. You just pick how many workers you want as each. The future of Mantle is actually not going to have any by default. And what we're trying to do is get Mantle to be an extremely small core that you deploy with just like a single binary, and then you just launch different infrastructure applications onto it as an application. So probably when we start moving towards Docker Swarm, we'll have that become more of an example. And Docker Swarm, when we add a scheduler, these are the kind of things that we try to integrate across all the different schedulers. So that's service discovery, overlay networks, it'll be Calico and Contive, deployment and management, and we'll talk about load balancing in a little bit, but that's kind of, can we have common tools that work across the different schedulers so that you don't get locked into one thing. And a big part of this is that the different schedulers have different strengths. Right now, Apache Mesos is really good on the data side. It has a lot of good data frameworks like Kafka, Elasticsearch. Apache Spark was originally developed to run on Mesos, so it has a really good tie-in. When you look at the container side, right now it looks like Kubernetes is dominant. It's really starting to pull ahead of the other scheduler options. I may do a little demo here to show some of the API and interface. So this is what the Mantle UI looks like, and there's this is actually dynamically populated. We actually are starting to use the console KV, which there's a KV store at the heart of console, and we're using, this is an Nginx proxy here, and it's dynamically updated by things in the KV and the service discovery system. So as new services get registered, we can have some information about how they're represented, and they automatically pop up here. And another thing you can see is that we have, this is SSL unauthenticated, so like things like Mesos, which don't have really good authentication. We have like links to the Mesos workers, all controlled via SSL. There's also, all the services have health checks built in, so you could see what the state of it is. So we could talk about some of these. I don't know what. So this is, if you've ever used Mesos before, this is like a simple application launcher. I just have a hello world here, and what I'm going to do is I'm just going to scale this to like 5 instances. And once that gets up, I'll show you. This is our load balancer. Oh, it's already up. Yep. So basically, as I said, because we have really good integration through the UI, as soon as you bring this up, and you see here, there'll be the address, right? We have hello. I can get that, but it's hello, and we have GOTO, that subdomain that I put in when we built up the cluster, so it automatically maps it, and we just tell the traffic load balancer, hey, that's the domain you have to listen on, and it'll match the headers, and then you can see all the backends here. We could just go, there's a 404. This was when I had to shut the cluster down, but when you start it now, you can see the different container IDs coming on down here. And when we suspend this, it's pretty fast. Like we'll just shut that off and that's it, right? So we have the edge nodes. The edge nodes are actually designed, well, I'll talk about traffic in a minute, but we actually sponsored development of it. We thought it was really great, and we added some things like marathon health checks in it. So if a container is up and it's unhealthy, it doesn't get routed. A couple other things in the Mantle UI. If you've never seen any of these, obviously we have the Kubernetes UI that you can get to, which is similar. I want to talk about Elasticsearch because it's a product that Container Solutions developed, the framework, and it's really cool. We have good integration with it, including down to service discovery. So you actually launch this as a framework, as an add-on. It's not part of core Mantle, and when you launch this within about 5 minutes, it gets launched, and then it pops automatically, comes here. So you can go there, and if you've ever seen the Elasticsearch that Container Solutions has developed for Mesos, it's really slick. You could scale it. You could see the tasks that are running. You could, and this usually comes up in about 5 minutes. So it's really good. And we automatically register these things in the UI, and we have a Kibana that actually, as I said before, we have automated logging. So if you install ELK, a lot of the logs will go into Logstash, and you'll see here they'll just get populated. For our logging story is changing a little bit. We're moving away from Logstash towards Elastic Beats, and we're also moving everything as much as we can out of syslog into journal D. So that'll be ongoing. I'll talk a little bit more about events and logging later, but again, this is something we have built in, and you don't even have to point to the local Logstash. You just change a couple of variables, and you can push it out through an Elasticsearch cluster. Let's see what else we have. I'll make this a little bigger, just an idea of how things work. You could actually look at, you could run we have this tool that we developed called Console CLI, and I just said, hey, is there anything warning in the entire cluster, and it comes back with nothing. So you could be an administrator, and you could just run this and say, hey, is there anything bad in my cluster? Or you could have like an external system like Nagios just pull the console API to see if any health check is failing, or if anything's misconfigured. And if I say, hey, what's passing? Let's see here, if I have one. Yeah. You'll come back with everything, right? And you can see you see the health checks here that we do? So we have built-in health checks. So a lot of the components were built into. So this is live. So again, something you'd have to do yourself if you deployed Mesos. How do we get it health checked? How do we register it in service discovery? That's all automated. And it's very easy to do. If you want to add services to console yourself, you either talk to the API with a JSON, or you just drop a JSON file into the etc console directory and reload it. So if you want to improve upon our console installation, having your own things that you want to deploy, it's very easy to add them into the health checking. Another thing we do because of Terraform is we have an external volume here that actually, so the way we do Docker storage, if you've played with Docker storage a lot, it's a huge pain and there's a lot of bugs in it. We actually attach an external volume to the systems, like an EBS, and we format it with overlay FS on XFS so you can increase it. And we log all Docker stuff to journal D. And so before you had JSON file, which was a pain, or syslog, which didn't support Docker logs. We're using journal D, and we're using the newest Dockers, or the newest Docker version. So just kind of some of the things we do there. We also have a lot of other cool features that I would show on the low level. Because we have this service discovery system built into our thing, we actually have dynamic IP tables, like the Marathon instances between each other can only talk when you bring up a new Mesos worker, it actually opens up the firewall and the control nodes for you dynamically. And it's only a few lines of code. It's basically a bash script that gets called that pipes in some console template data. And it's all dynamic, and it actually works really well, which is shocking because most things in infrastructure don't. Right? Yeah. Well, this is a worker, so it doesn't have it. Yeah, you can see here. You see the Mesos leader. There's a rule there, and it actually has, as workers come out, the firewall actually gets opened up on the fly. So things that would be really confusing, like how do you do dynamic firewalls in console template, it's actually very simple. Okay, we'll get back to the presentation. I may show console a little bit in the future. Another thing we have is a Mantle API. So basically, this is kind of it actually stores all its data in the console KV, and it's a Golang service that sits on the cluster. And if you want to install something, when Ken Sipe was showing some of the things about DCOS, it's compatible with a lot of the Mesosphere packages. It uses some of the same packaging format, and we basically have it via an API. So yeah, within like the Elasticsearch framework that we just brought up, or Kafka, or anything like that, you just hit the one API point, and it comes up as a Mesos framework, and then you can manage it. So it's actually really easy for bringing up data services on Mesos. I want to talk about load balancing. So you saw a little bit about it, this tool called Traffic. This came out in September from an engineer in France who was working for a DevOps shop. And when we saw it, we thought this was fantastic. So we started sponsoring a lot of the development. We actually encouraged him to start his own company. So I'm very excited about that. He just incorporated in January. And we sponsor a lot of work on Traffic. We sponsor the Kubernetes ingress. We're sponsoring TCP/IP support into it, so it could be a TCP balancer. And I think you saw a little bit about it. We installed on edge nodes. It supports multiple backends. This is what we like about it. If you've ever used, like, a lot of places will use like HA proxy, and I'll do reloads. We first started using HA proxy to proxy our traffic, and we found that reloads were really difficult. Reading from like Marathon, all the the data that was coming out of Marathon changed a lot. There was a lot of things that were broken, so we started using this, and the number of outages we had due to load balancers went down by an order of magnitude. It supports WebSocket, SNI support. It just got Let's Encrypt support, but it's not multi-node yet. But if you have one traffic node, you can enable Let's Encrypt for SSL. The other cool thing about this, we talk about not going through IT. When you launch an application, you just set some labels in JSON. So the developer says, this is how I want it to listen to traffic. This is, I want to pass host headers. This is the URLs I want to match against. So this is not something for IT. The developer, when they launch their application, like when you launch a Kubernetes manifest or a Docker container, there's some metadata that you could attach, labels. And the developer just updates that, and that affects the way traffic will route the traffic. So that's something we think really cool. It has multiple backend support, a good community, and we like this dynamic labeling. Now the Kubernetes support, since we just landed last week, so we haven't integrated it with Mantle yet, but when we do, it'll be similar. There'll be multiple backends, and you can just say, hey, this is the Kubernetes traffic, this is the Mesos traffic. So yeah, I'm very excited about this project. I think it has like 1,800 GitHub stars on its own within a year, so it's pretty popular. And he's adding a lot of Docker Swarm support. There's console support. There's etcd backend, so you could basically use this to route anything. As I said before with Mantle, we pick tools that we really like, that we think people would use anyway, and we integrate them together. Next thing I want to talk about is the community. That's really important for us. Just some growth of our community. The project came out of, it started last February, so it's a little over a year old. We first open sourced it in April. We just got over, it has decent growth going on. Over 2,000 stars. We're getting about 100 a month. And there's a Gitter chat. So if you just go to the Mantle page and you just click on the Gitter button, you'll actually get in the chat and we'll help you in real time if you have any issues installing it or anything. So for us, open source in the community is really important. So that's kind of a summary. I have 2 minutes and 45 seconds. Really what we want to do with Mantle is we want to deploy it in minutes. A big thing for us is batteries included, right? We want to have a lot of the things that people need, like logging, security, HA, all built in. And really important to us is it's kind of different than a lot of the stacks you've seen because those tend to be vertically oriented because they want you to all use their own stack. We kind of think ourselves something similar to like a Linux distribution, like an Ubuntu or a Red Hat, where we take open source tools and we integrate them together, right? Like that. We think that organizations are going to have lots of diverse needs. So we're thinking about how do we actually build a platform for the next generation of infrastructure where you could kind of morph it, to deploy different kinds of workloads. And when new tools come out, we can integrate it with the rest of the stack. I want to talk about the future. So this is probably, hopefully we can get a lot of this done by the end of this year. We use Ansible for a lot of provisioning right now. We don't want to. I just think in general, the problem with a lot of these DevOps tools like Chef, Puppet, Ansible is that they're extremely complex and there's usually only like 1 or 2 people who wants to touch them. So I just don't think that they're going to be the future the way people manage infrastructure. Single binary deploy, we're still going to use Terraform, but we'll wrap it. But you'll have a single Go binary that says mantle install AWS Docker Swarm. Right, and it'll have Terraform under the cover. So all the amazing stuff about Terraform will still be there, but we'll have that. It's very important for us to have that user experience. Move apps, and I kind of talked about this a little bit. We want a really small core for Mantle. We just want to have just enough to bring up the cloud provisioners and enough on it that we could then start deploying all the other apps. So the first thing will be things like schedulers, like Swarm or Kubernetes or Mesos, and after that, we expect the other apps to talk to those. Like there's a Kubernetes package manager called Helm, and you can use that to bring up your next level of applications. And finally, Event Bus. This is something we're working on right now. This is a lot of work that Cisco's interested in. All the Mantle components are starting to be, we're giving them Kafka outputs, so like Docker events, Marathon events, traffic events. Anything that's in the cluster will spit out all its data to Kafka, and there'll be actually a Kafka bus that's optionally built in. So if you turn this all on, all the things will start spitting out their events to Kafka, so you can start across the cluster. So again, I don't think a lot of folks are doing that, but we hope to have a lot of that work done for Cisco Live in July. So you'll be able to, because a big problem when you're launching apps in the real world is that you launch a container and it'll get stuck somewhere and you don't know where, right? It'll just not run. And then you have to actually trace all the steps. Like when you actually launch a container, there's a whole bunch of things. It's like, is the container built? Was the image pulled down successfully? Did the image start? There's a whole bunch of steps that happen. Was it scheduled on the right node? We found debugging, it's very hard. So that's why we're putting events into everything. And that's about it. And I got 15 seconds. We'd love you to try it out. Get on Gitter. We expect, our goal is that everybody can install it themselves, maybe with a little help the first time. But yeah, that's really our goal. So just go to ciscocloud.mantle. Thank you very much. And please rate this talk well.
So, apparently, Stephen, you lost someone along the way here, because one of the questions was, what is the big picture here? What problem is it that you're trying to solve?
The biggest problem right now is that there's a huge demand to move to these next generation technologies, continuous delivery, streaming infrastructure, right? And to actually build up an infrastructure to do that for your company is extremely hard. It's going to take you a very long time. Even if you try to use one of the services, like if you set up an Amazon ECS, it's still very complicated. I've set up ECS for customers, and you still have to wire in things. And ECS is very limited, and then to set it up for Docker authentication, it's very complicated. So you're going to find that most companies don't have the time or the resources to do this. And in all honesty, every minute that you spend writing your own unique infrastructure is a minute that you're not spending on your customers and products. You know, and that's what we're telling. So I tell the engineers one thing, but when I go to C-level executives, I'm saying every minute you spend on DevOps, on operations, on building your own infrastructure is $1 that you're not spending on your customers and product.
So would it be fair to say that Mantle is like a set of sane defaults for setting these tools up together?
It's like a Linux distribution. You would not do your own Linux distribution today. So the idea is the same thing. We're trying to get away from this idea that everybody's going to glue together their own snowflake infrastructure of gluing these components together and you know, taking forever and then having to deal with it.
So how do you actually configure it? Right? We didn't see any examples of that.
Right now, it's a lot of Ansible. One of the things we're going to is, we're actually starting to move towards KV based, like using the KV to manage the cluster. So this is something that will be in the future. It's starting to get there now, but we have to move a lot of the components out. So if you look here in the key value storing console, you're starting to see do SSL. We're starting to put configurations inside the KV. So right now, a lot of it's in Ansible, but we're actually going to move to is actually everything's going to be managed out of the KV store. So we don't want that separate DevOps tool. So you'd actually hit the console API, update a key value, and then the nodes themselves would reconfigure themselves.
Okay, so the way you do it today is that you go in, you modify some files.
Yeah, it's Ansible based today.
You clone the repository and then modify it, and then okay.
And yeah, we just don't think that's a good pattern in the long term. So we're moving towards.
What are the benefits? I mean, if you're running something like Kubernetes, which already has a lot of batteries included, what are the benefits that I get out of Mantle compared to that?
Well, there's things outside of Kubernetes that you may want to run. Right now, the data store in Kubernetes is not necessarily great. Like a lot of the big data frameworks, they're starting to come. Like Kubernetes is probably going to have the leading container ecosystem at some point, but right now a lot of things aren't there. We're talking about the different communities, so things that don't run in Kubernetes, your services, right? Like lower level things or service discovery, or as I said, like if there's a data framework that runs somewhere else. Our idea is more of a generic, as we said before, we don't know who the winners are going to be, so we're putting together general patterns for running any kind of infrastructure.
You're betting on old horses.
It's not that. It's kind of like Red Hat doesn't bet on MySQL versus Cassandra, right? They provide a common platform.
Okay.
And that's kind of the idea for us, making all of these infrastructure tools an app.
Last question. Do you think Chef and Puppet are going to die, go away?
I don't think they're going to go away, but I think if you look at any organization that uses Chef or Puppet, there's usually 1 or 2 people who touch it, and nobody else wants to touch it because it's very error-prone. It's very complex, and using Git to manage infrastructure is not always a great pattern. We see that a lot with, like when we want to update infrastructure, like having to update things in Git, you have conflicts and a lot of other things. So we like the idea of moving, you know, containers that are versioned, packages that are versioned. That's kind of the pattern that we like.
Okay. Thank you, Stephen.
Thank you. Thank you, everybody. I appreciate it.